Thank you everyone for coming and being at this talk. All the talks have been so great, so I'm honored to be up here. So, today's talk is called XProtect, Stop, Drop, and Shut Malware Down Before It Opens Up Shop. I don't normally wear graphic tees for talks, but I wore my DMX shirt today for this talk. So here's to hoping you've heard of DMX before. I'm trying to successfully blend Mac OS security and 2000s hip hop. So let's get going. My name is Stuart Ashenbrenner. I am a Mac OS researcher at a company called Huntress, where I focus on security and development. You can find me across most things at Stuart J. Ash. Similar to Thomas, I use my middle initial as well, although Stuart Ashenbrenner isn't the most common name. And on GitHub, I've helped co-create and am the primary maintainer of an open source incident response tool called Aftermath. So please check that out. So today, we're talking about Apple and some of their built-in tools, how they look to block and then eventually remediate malware, and more specifically, XProtect and XProtect Remediator and the relationship between the two of them. And the main question I look to answer today is, are XProtect and XProtect Remediator enough for you as just a standard user, for your company at scale and things like that? So there's really three fundamental building blocks of built-in macOS security, and it's this idea of check, block, and remediate. The check portion is covered by Gatekeeper, and that would take a little too long to dive into. So we're going to focus on blocking and remediating, which fortunately for us maps over nicely to the two tools that we're going to talk about today, which are XProtect and XProtect Remediator. So we'll dive in and talk about XProtect first. Trying to integrate a B as well. So what is XProtect? It checks for known malicious content whenever an app is either first launched, somehow it's been changed within the file system, or XProtect's signatures have been updated, and we'll talk more about those. It's also part of the com.apple.xprotect subsystem, which we'll dive into a little more when we talk about unified logging. So XProtect is in an XProtect.bundle, and it's down this long line of folders in library, Apple, system, library, core services. And we see two XProtect files in here, an XProtect.app and .bundle. So we're going to talk about XProtect.bundle. So if we kind of drive all the way to the bottom of that, we meet 5 files. We have one YAR file, 3 property lists or P lists, and a SQLite database called gk.db. So we'll quickly touch on what each of these are. So XProtect was originally designed to check for outdated Flash and Java, and that's actually what we see in this XProtect.meta plist. So if we actually scroll all the way to the bottom first, we actually see that it's doing just that, looking for outdated Java and Flash still to this day. However, if we jump all the way to the top, we see that it's also looking to block malicious extensions in Safari. So we see this com.searchnt.safari bundle identifier, as well as that 10-digit developer or team ID associated with it that XProtect is looking to block. If we pivot to the next file, just xprotect.plist, this blocks a plethora of different things by using some different entries in this long plist. So if we pick one that might look most familiar, if we scroll down just a little bit, we see a familiar piece of Mac malware called Bundlor. And if we zoom in, we have kind of 3 main entries. We have the description, which is the name of the malware. In this case, it's a variant of Bundlor, bundlor.d. We have the launch services, and this is the URI type it should trigger on. So that ls item content type, this will say something like an application bundle, installer package, Word document, etc. And lastly, it's how it's going to match and detect it. So this is an array of dictionary objects. And using that NSURL type identifier key near the top, that's how it's going to detect the malware. We next have a file called legacy entitlement allow list. This was introduced in early 2020 at the same time as XProtect version 2114, and it's just a long list of over 42,500 CD hashes. And Apple doesn't really have any documentation on what this is supposed to mean, but based on the name of the file, it's macOS that needs some type of legacy entitlement in order to run. Next up, we have probably the most interesting file to me, at least, which is the XProtect.yara file. Now, this was released in late 2017, and this is a static list of Yara rules. And it all has these kind of obfuscated names for the most part, so you can't really tell what it's trying to detect. And how Yara works is, as opposed to looking at a specific file hash, which would be like a fingerprint, this is looking for commonalities, slight commonalities, maybe similar bytes in a file, similar strings in a file. So it'd be more like looking at the shape of a hand as opposed to a specific fingerprint. And last is this SQLite database. Now, called gk.db, this actually is used by Gatekeeper as well, and we'll talk about more how that works here shortly. But it's pretty straightforward. It has two primary tables, which are blocked hashes and blocked teams. If we looked at the blocked hashes table, we have 546 hashes in here. Of course, using terminal, right? It's binary data, so it doesn't read it super well. But if we look at blocked teams, it just has two columns, and it is team IDs or developer IDs that it blocks immediately. And there's 132 in here. So let's look at this in action. So we have a file. Hopefully you all can see that. Sitting there on my desktop, just a zip file, and we can see that with the file command. If we look at the extended attributes of this file here, we see that it has the com.apple.quarantine extended attribute. And we're going to talk about how that works. This is assigned by file quarantine when a file is newly downloaded from the internet and hasn't run yet. So if we unzip this file and pass it a password, because this was downloaded from a malware service, we can actually see that this file also carries on that quarantine attribute. So I downloaded this malware knowing it should be blocked by XProtect. So let's see if it does. We can use Yara just built in, suppress some warnings because XProtect Yara isn't the most performant, and then pass it the XProtect Yara file, and then point it at that file. So basically, we're running Yara, all the Yara rules in XProtect.yara against that one file. And when we do that, we see that XProtect rule called macOS 1DB9CFA detects this. So we haven't done anything with this malware yet. It's just sitting on our desktop. So instead of just running this malware, let's just try to access it. So we're going to use just a hex editor called hexfiend, and we're just going to try to open it in hexfiend. So again, we're not running the malware. We're just accessing the binary contents of it. And XProtect does indeed block it. And that's because it had that quarantine attribute assigned to it. And that's also why we get this nice little reference in here about what Yara rule was used to block it. So keeping this image in mind, saying, you can see it says it contains this specific malware. If we actually just go back and remove that extended attribute, that com.apple.quarantine, by just doing xadder tacrc and point it to the file, it'll remove that quarantine attribute. And then if we try to access it again with our hex editor, we'll see that it opens no problem. So that's how that quarantine attribute helps inform XProtect and Gatekeeper. Again, this is just accessing it. So if we actually do try to execute this malware, XProtect does see it. We have to make it an executable, chmod +x, and then running this file, XProtect catches it as expected. So when we do it this way, we still get that alert, which is from the core services UI agent, but we see now it lacks that context of what rule picked it up. So one of the difficult parts about XProtect is kind of the visibility into it, what it's detecting. Now, there are some unified logs for XProtect. They're not the most verbose, but we can look and see what those are. So if we kind of tap into unified logging using log show, and we pass it the predicate of the subsystem com.apple.xprotect, we can actually see some of the information or the things that are happening with XProtect in the background. So we'll see once it runs that it's looking at the like xprotect.metap list and some other things, doing some assessments and performing some scans. So all the logs are fortunately right here. So just to reiterate, XProtect doesn't just apply to process events, but it's also these access events. So kind of these two things happening in tandem in combination with Gatekeeper. So I want to pivot a little and talk about XProtect Remediator, which is relatively newer in comparison to XProtect. And it was down that same line of folders, but this one is called xprotect.app. And this is in typical application bundle structure. So if we dig a little deeper, we have the contents/macOS folder. Typically at the base of this, we would find our binary for any typical app. But instead, here we have 20 Mako executables. And most of them are prepended with XProtect Remediator followed by a name. And that is the family of malware it's trying to detect. So instead of like reading all these out, we can see it would be like XProtect Remediator add load, and that is trying to remediate add load malware. Some of these are new, like within the last couple weeks. I think Cold Snap was just released in the last XProtect Remediator version. And so there's a lot of things that XProtect is trying to remediate here. One of the great things that XProtect has been kind of pushing towards, XProtect Remediator that is working with endpoint security for a little more context into what's happening. However, if I run malware in this giant JSON object, there's really just this one little section that talks about what's happening with XProtect Remediator. So it says there was malware detected, what malware was identified. Again, I ran this right after running that malware earlier, and we can see the path. I have found this to still be a little unstable. I can't get it to work every single time I run it. So I think it's still in the works from Apple. And again, there's a lot of information in here, but not much of it is incredibly applicable to this XProtect event. However, one of the best parts of XProtect Remediator is its unified logging, and it's gotten much stronger. So instead of kind of setting up a whole nother scenario, we're just going to fast forward through kind of what we talked about just moments ago and get right to the unified logging, and we'll look at the XProtect Remediator unified logging for this exact same event that we just saw. So this time, instead of using our com.apple.xprotect subsystem, we're going to specifically look at the XProtect framework.plugin API, as well as make it even a little more, drill it down even a little farther and specify the category being xpevent.structured. And this will give us a great kind of collection of events. Now through your MDM, a lot of times you can do unified logging and collect logs and things like that. So this may be helpful. So here we see kind of the malware name in pink or purple, as well as if it detected a threat, how long it took that binary to run, and if it found anything. So again, the main question I wanted to address was, is this enough? Is this enough for a user? Is this enough for your company? And the analogy I've used is like maybe for your crazy Auntie Toby who just like uses her computer for online poker, maybe. However, at scale, it becomes really difficult to justify just using Apple's built-in tools. And there's a few reasons for that. The first one, I think, is visibility. There's not a whole lot of visibility into XProtect and XProtect Remediator. There's some kind of nuanced things, race conditions if you have your own third-party endpoint security agent running. The second is that Apple's XProtect rules, like their YAR rules, have to be incredibly specific. They can't risk a false positive. These get pushed out to millions of endpoints. It's not like just a small subset of computers. It's tons of machines. So they can't risk a false positive. And lastly, the majority of XProtect stuff at the moment has a pretty narrow scope, right? Focused on signatures and not necessarily behaviors for like more sophisticated attacks. And that brings us quickly to kind of forward looking into macOS Sonoma. And Apple, I can't really say it's been teasing this, but they have released some experimental features in this VAR-protected XProtect DB database file. And it appears to be behavioral detections. So Apple kind of digging into this, which is great. So if we just look at all the events right now in that events table, there'll be quite a lot. So instead, we'll just look at kind of what these columns are. And within these columns, we can actually see what Apple and XProtect Remediator will be looking for. So it's going to be things like the executing process ID, the path of it, the responsible PID information, as well as any profile hash and things like that. So this will give context, a lot more context, either to Apple or if they make this consumable to third-party vendors for behavioral-based detections. So quickly, just if I just select one of these, it's like something from my browser, some kind of behavior my browser's doing. Again, this is experimental, so I'm just going to chalk it up to that, or that I'm doing something weird on my computer. That's possible too. But it's awesome to see that Apple is, instead of just focusing on signatures and signature-based stuff, looking into these behavioral detections, which is really great. All right, that was a lot of information.